All right, let's look at the homework 3.1, problem number 7. All right, so we want to find equations of both lines through the point 2, negative 3 that are tangent to the given parabola y equals x squared plus x. All right, so let's do that. So I drew a ballpark picture. So this is the parabola, x squared plus x. Then we have this point, 2, negative 3, and we should be able to, in this case, draw two separate tangent lines. All right, so let's find them. All right, so since we don't know the point of tangency, so what we're going to do is we're going to actually call it something. So I'm going to call this point of tangency A comma B, something like that. All right. Then what we're going to do is I'm going to try to express the slope in two different ways. All right. First, I'm going to try to use the slope formula. Right, slope formula. Right, so slope m is going to be, so let's write m is going to be, right, so we can just think of, say, here, this is going to be x1, and then this is y1, and this is going to be x2 and y2, right? So if you do y2 minus y1, so it's going to be a b minus negative 3, so b plus 3, right? Over x2 is a minus x1 is 2, so minus 2, right? And better yet, since we know that the point of tangency is on the parabola, we can actually write b as, you can just plug a into the parabola. So you have b, same thing as a squared plus a. So we can actually write it as b is a squared plus a plus 3. And then we're going to divide through by a minus 2, right? Then we're going to express the same slope using derivative. So number 2, we're going to use the derivative. That is, so we take the derivative of this parabola. So we know that the y prime is equal to, right, derivative of x squared would be put 2 in front and x, and then subtract 1 from the power. It's going to be 1. And derivative of x is just going to be 1. So we have that, right? So the slope m can be found by, right, take the derivative and then plug in the x coordinate of the point of tangency. So this is going to be a 2a minus 1, right? But since we're talking about the slope of the same tangent line, these two values must be the same. So what we're going to do is I'm going to set these two guys equal to each other, right? So let's do that. So you have a squared plus a plus 3 over a minus 2. Right, this is equal to 2a minus 1. Right? Then, since I don't like fraction, I'm going to try to multiply both sides by quantity a minus 2. Then you get, so a minus 2 cancel out, so you have a squared plus a plus 3 is equal to, and if you multiply this out, so you're going to get the 2a squared, right, and the negative 4a and the negative 1a, so it's going to be negative 5a. Actually, I messed that up. So this is plus, sorry. So let's see, I have to change this. So if you do that, you're going to get, let's see, so negative 4a plus a, so it's a negative 3a. And then negative 2 times 1 is negative 2, right? Then I'm going to just put all terms on the right hand side in this case. So to do that, I can just subtract the a squared, subtract a, and subtract 3, so that you have a 0 on this side. Right, so a squared minus 2a squared minus a squared would be 1a squared. Negative 3a minus a would be negative 4a. Negative 2 minus 3 is negative 5. Right? Then we can actually just factor it out as a plus 1 times a minus 5. Right? Which means that a has to be setting that equal to 0, negative 1, and setting a minus 5 equal to 0, so it could be 5. Right? So you can see that here we have this these coordinates. So this one right here, right, has coordinate 5. So its x coordinate would be 5, comma. Right, then we can just plug this into the parabola here. So if a is 5, b is going to be, maybe I'll just do that, a is 5. Let's see, when a equals 5, then b is going to be equal to, plug in 5 squared, so you have a 5 squared plus 5. So that's 25 plus 5, so it's 30. So we know that one point of tangency is 5, 30. And the other one is going to be if a is equal to negative 1, then we know that corresponding b would be negative 1 squared plus negative 1. So that's going to be 0. So you can see that this point of tangency there is negative 1, 0. All right, so you're going to have a 2 tangent line. I'm going to call this one tangent line number 1, and then call this one tangent line number 2. All right, so let's try to find the tangent line number 1, but we know everything we need, right? So here, the slope there is going to be, all you have to do is plug in negative 1 in here. So you have slope m. Right, so slope for this guy, m, is equal to 2 times negative 1 plus 1 is negative 1. And for the other tangent line number 2, slope is going to be m is equal to, right, so a is 5, so 2 times 5 plus 1, so slope is 11 on that one. Right? So we can come up with 2 equations. First one, so tangent line number 1, we're going to have y minus y1, which is 0, is equal to, slope is negative 1, x minus x1 is negative 1, so it's going to be plus 1. Right? So if you simplify that, you're going to get the y is equal to negative x minus 1. Right? And the tangent line number 2 would be y minus 30 is equal to, slope is 11, times x minus x1 is 5. So if you simplify that, so this is going to be 11x minus 55, then we can just add 30 to both sides so that the y is equal to 11x. Negative 55 plus 30 is negative 25. Right? Let's type it in. All right, so we're going to get, first one is negative x minus 1. And then the other one is 11x minus 25. Right, let's double check. And that's what we have. Let's check the answer. All right, it came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.